All right, everybody, welcome back. A long spring break, and I'm sure you're as excited to be back as I am. So we're going to make today's video short and sweet, get it over with quickly for you. And we're talking about theoretical probability, which is something that you use all the time and you may not even realize it. But theoretical probability, couple definitions to start with. Probability is kind of the first part because to talk about theoretical probability, you need to understand probability. And probability is just the chance of something happening. So I'm going to write that down right here. Probability is just the chance of something happening. So pause the video and write that down. Probability is the chance of something happening. Like, what is the probability that I flip a coin and get a heads? Or what is the probability that I win the lottery? Or what is the probability that I make this free throw shot? Okay, what's the chance that something's going to happen? This form right here, this isn't really a definition. It's more something I want you to get used to seeing. The P in front stands for probability. And what this form is representing is what is the probability of this event happening. So it would be, what is the probability that the event, whatever's in the parentheses, will happen. So what's the probability, that's what the P stands for, that this event is going to happen? For example, right down here, what's the probability that I get an odd? Or what's the probability that I pick a number greater than 5? So that's what this one represents. Relative frequency, when we write probability, we write it as a fraction. Relative frequency is when we actually divide that fraction. Relative frequency is the percent form of our fraction. So it's just what it looks like when we actually divide it. So it's the percent form of our fraction. Theoretical probability. Now that we know that probability is the chance of something happening, theoretical probability specifically is what is the chance of something happening in theory? Or in other words, what should happen? So what should happen? Okay, for example, if I flip a coin, I should get heads half of the time. I should get tails half of the time. There's a 1 in 2 chance. That's my theoretical probability. But that doesn't mean every time I flip a coin, I'm going to get heads, then tails, then heads, then tails. And we'll talk about that more a little bit another day. But theoretical is what should happen when we do an experiment or when something goes on. So this little graph right here, just really quick, I don't know how much this will help you, but we've used it in the past and I just want you to have it. 1/2, that's the same as 50%. Hopefully you know that by now. Is equally likely to happen or not happen. That's like saying 50-50. 1 out of 2 chances something will happen. 3/4, 3 out of 4 chances something is going to happen is a 75% chance. And the words that we use are it's likely to happen. Okay? 75% is likely to happen. 1 represents a 100% chance of something happening. And the way that we phrase that is that it's guaranteed, that it will happen for sure. And then going the other way, 1/4 is like a 25% chance of something happening. And we say that is unlikely to happen. And 0 is a 0% chance, and we call that impossible. And we need to be really careful if we ever use impossible as something that could happen, because that one, although it's true, that we don't use it very often. There's not a lot of things that are completely impossible, but every once in a while it comes up. So let's talk about probability a little bit. Now we've got all that out of the way. You filled in that part. Here's our example. We've got the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And from above, we know that this is asking what's the probability of getting an odd. And what's the probability of a number being greater than 5? What's the probability of a 5 or a 6? So step one in doing theoretical probability is to count up the total number of possible events. The total number of possible events. In other words, how many total numbers could I pick? I could pick a 1 or a 2 or a 3 or a 4 or a 5 or a 6 or a 7 or 8 or a 9 or a 10. So total, there's 10 possible outcomes when I pick a number. So if I'm flipping a coin, there's 2 possible outcomes. There's heads and there's tails. So step one is to count the total number of possible outcomes. And what we're going to do with that, over here in parentheses, I want you to write bottom, because we're going to put those in a fraction, and that number goes on the bottom. So for our example up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 10 possible things that I could pick. So I'm going to write my fraction with a 10 on the bottom. Step two, we need to find out how many times the event that we want could happen. So step two is to find how many times the event that you want could happen. So if I look at this example, my event that I want is to get an odd. That's what's in the parentheses right here. I want to get an odd. So how many total ways are there to get an odd? Well, there's an odd right there. There's another odd. There's another odd. There's another odd. There's another odd. So there's 1, 2, 3, 4, 5 possible ways I can get an odd, and that goes on top. So you can put top right there. So first we count the total things that could happen, and then we count the total number of things we want to happen. And that goes on the top. So then we write our answer as a fraction, and we simplify. So 5 over 10, that's our fraction, but we simplify that to 1/2. And the way we read that is I have 1 out of 2 chances of getting an odd, because 5 out of 10 of them are odd numbers. So I have 1 out of 2 chances, or a 50% chance. So down here at the bottom, this fraction, again, on the bottom is the total possible outcomes. And on top is the number of outcomes that we want. And that's how we're going to write our fraction. So let's skip over to here. Probability of getting a number greater than 5. Well, the total possible numbers is still 10. That hasn't changed. So that still goes on the bottom. But how many of those numbers are greater than 5? Well, 1 is not, 2 is not, 3 is not, 4 is not. 5 is 5, which isn't bigger than 5. They're the same. But 6 is, 7 is greater, 8 is greater, 9 is greater, 10 is greater. So there's 1, 2, 3, 4, 5 numbers that are greater than 5. So that goes on top. And when I simplify, that's also 1/2. Or we could write 50%. Same thing. Next one, probability of getting a 5 or a 6. Again, there's 10 possible things I could get because there's 10 choices. How many of those are 5s or 6s? 1 isn't a 5 or a 6, 2 isn't, 3 isn't, 4 isn't. 5 is a 5 or a 6, and 6 is also a 5 or a 6. But 7 is not, 8 is not, 9 is not, 10 is not. So 2 out of the 10 of them are 5s or 6s, and that simplifies to 1/5. Okay, now the last one. What's the probability of not getting a 3? So we're looking for things that are not 3s. Well, 1 is not a 3, 2 is not a 3, 3 is a 3, so that doesn't count. 4 is not a 3, 5 is not a 3, 6 is not a 3, 7 is not a 3, 8 is not a 3, 9 is not a 3, 10 is not a 3. So we have a total of 10 possibilities, but only one of them is not, or excuse me, only one of them is a 3, and we want not 3s. So 1, 2, 3, 4, 5, 6, 7, 8, 9 of them are not 3s. So 9 out of 10 would be my probability. So my relative frequency, if I turn that into a percent, is just 90%. All right? So, well, that's theoretical probability. On top is what's the number of things that we want to happen, and on the top is what is the total number of things that could happen. So let's flip over to the back side really quick. We've got a few problems that we're going to do together, and then I'll let you do some on your own. So number one, you roll a die numbered 1 through 18. That's a big dice. That means there are 18 sides on it. What is the theoretical probability that the value of the roll will be 3? So what's the total number of things I could get? If it's numbered 1 through 18, I could get 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 18. So the total number of things that I could get is 18. So that's going to go on the bottom. What goes on top is how many times what I want could happen. And what I want is a 3. Well, how many of those numbers are 3s? That's kind of simple. Only one of them is a 3. So my probability is 1 out of 18. That's my probability. And maybe that's something that we should write on the front right here. This line, we say out of. Okay, 1 out of 18 chances. So when we read that, there's 1 out of 18 chances of getting a 3. So number 2, a weather forecast during September says that it will likely rain 2 out of the next 5 days. If the weather does not change, what is the theoretical probability it will rain in the month of September? Okay, so what are the chances that it's going to rain? Well, out of 5 total days, 2 of them it should rain. So 2 out of 5 days it should rain. And then if we look at the month of September, there's a total of 30 days, I think. I really hope there is. And out of those 30 days, how many of them theoretically should rain? Well, if 2 out of 5 rain, that means that 4 out of 10 would rain, and 6 out of 15 would rain, and 8 out of 20, and 9 out of 20, or excuse me, 10 out of 25, or 12 out of 30. So I'm just going up. I go up by 5 days. I'm going up by 2 days. So out of 30 days, 12 of them would rain. Which, when I simplify, just becomes 2/5. So I'm done there. Number 3, twins Denise and DeAndre always flip a coin to decide who gets to ride in the front seat to school. During a 6-week period, 30 school days, what is the theoretical probability that Denise will get the front seat? Well, if they're flipping a coin, there's only 2 results, heads and tails. So that goes on the bottom. And Denise wants one of them. That goes on the top. So there's a 1 out of 2 chance that Denise is going to get the front seat. The time period doesn't matter, but there's 1 out of 2 chances. So out of the 30 school days, that would mean that there's 15 days, theoretically, that she should ride in the front seat. All right, time to pause the video. Try these 3 on your own. When you're finished, bring it up to me. Show me how you did. Good luck.